Now, after blocking out all the undesirable undercuts in the master cast, on which we are planning to design or creating the wax pattern for the removable washer denture and relieving all the areas that need to be relieved, the duplication will be next step for us. What is the duplication? First of all, we should know that we have three types of casts with the removable partial denture. Start with the diagnostic cast on which we are planning our design on it, and if we need to prepare it for in term of surgical or any other treatments with the abutments. And then we have the master cast on which we are planning to make a relief, blocking out the undesirable undercuts, and to identify the height of contour in term of the ditch for the clasps. Then this master cast should be duplicated into a refractory cast to create a cast can withstand the highly temperature inside the oven, because we are planning to waxing the partial denture design on it, and then cast it using metal. So in this image we can notice that the master cast number one, the refractory cast on which we are designing our removable partial denture design, and then after casting this we are going back to the original master cast to see our framework. Now, what is the duplication? The duplication, it is the procedure essentially consists of an impression, of course, taking to duplicate the master cast, then burying the impression by investing material to have refractory cast. Now, with the material that we are using in removable partial denture, it is easy for us to reversible material. The agar-agar can be used to duplicate the master cast. Agar is the duplicating medium of choice. The blocked, relieved, and beaded master cast should be duplicated so that the resultant refractory cast ideal to fabricate the framework. Now, a duplicator is a machine used to prepare and load the duplicating material into the duplicating flask. And we are going later on this machine, which is called the Gelovit, on which we are melting the agar-agar in a specific temperature to be poured into the duplicator flask. Now, the careful preparation of the master cast for production of this investment involves considerations. For example, if we are now planning to duplicate a master cast for the construction of removable partial denture. Then the first thing is to define the path of insertion. Of course, after surveying the cast, we determined the height of contour, the location of the clasp, whether it is a gingival approach or occlusal approach, the desirable and undesirable undercut, relieving areas. All of these should be identified. Also, the path of insertion is important to be identified, whether it is anterior posteriorly, posterior anteriorly, right to left, left to right. It depends on the measurement of the undercut that we have. Now, of course, the height of contour of the abutment teeth that we are planning to use for the retention, the retentive area or the retentive tip in terms of desirable undercuts, so whether the clasp going to approach with the RBI gingivally approach or occlusally, the ringy clasp, whether it is buccally or lingually, or using any other types of the retentive component. Now the stabilization area designed into the mouth preparation also. Now all of these should be considered before the duplication. Otherwise, we're gonna need to re-duplicate the master cast. And of course, if we have a shaped or arbitrary block out, this is essential because we are looking for a definite digits or shoulders to put all the components of the removable partial denture on it. Now, with the material that we are planning to use, instrument and equipment in the duplicating, so if the dental technician planning to duplicate a master cast, we need first of all the duplicating material, which is we have a reversible hydrocolloid agar-agar impression material, and this can be, of course, as a reversible, can be remelted again and again, regarding removing all the debris on it, which should not be included within the design. We have a colloidal silica, we have beeswax, and we should have a phosphate bonded investment material, and this for the investment material to create the refractory cast. Now, the agar-agar impression material, which is the reversible hydrocolloid, it's aqueous impression material used for recording maximum details because of the flexibility, the nature of this material, giving all the details that we are looking for within our design. Now, the reaction that passes by agar called gelation process. That's mean, so the gelation process is the process of melting the agar-agar. Now, the setting of this material, often called gelation, the gelation part is the liquidy feature, and the setting part is the solidification process. Now, the reaction can be expressed sol, gel, gel to sol. That's mean sol, that means it's liquidy, to gel. Gel will become like a gel texture, and then after, for example, pouring it, the gel going to solidification. Okay, so the solidification is the material can be purchased in a solidification. That means hard, and then become a gel, and after gel solidify again to be hard. Of course, not the hard that's with the word meaning that hard. That means going into original form. Now, the temperature that which the agar-agar turns to solidification, it's a liquefaction temperature, and of course return to gel to transform to gel. So the liquefaction temperature, it's probably different than the temperature at which the agar turned to the gel. And the liquefaction actually between 17 to 100, but generally we are looking for a gel. So overheating the material lead to a liquefaction temperature. That means become more liquidy, but we are looking for a gel texture. So the temperature between 37 to 50 and sometimes 52, this is the standard melting temperature for the agar-agar using the machine, of course, timer, and setting the temperature to have a gel form agar-agar. So what I would like all the students to remember that the liquefaction is between 17 to 100, the gel between 37 to 50 centigrade, and almost we are using it in temperature 52 and sometimes 54, but not exceeding 55. This to give the material a proper flowing over the details without melting the block out material or the relief material in the master cast. Now, the exact gelation temperature depend on several factors, of course, because if we purchase the material generally with which is non unexpired, so the material, we should follow the recommendation. But if it's a reversible. If we reuse the material, we need to add, for example, water for it because of the humidity. The material become hard and brittle and can be easily a tear. The factors that could affect the gelation of the agar-agar molecular weight, of course, the purity of the agar. If we have some debris with the reversing or remelting or regelating the agar-agar, this will affect the gelation as well. And the ratio of agar to other ingredients. Because of the using the material several times, it is to be recommended to can be used for 3 times and then can be discharged. Otherwise, the material become easy to tear and losing the properties of the gelation to give the details. Now, the instrument that we have also to duplicating flask, we have the feeder ring, the rubber suction cup, uh, for extracting cast from chilled mold. Now we have a rubber bowl. We have a rubber bowl, for example, laboratory spatula for stirring duplicating material and for mixing cast material in plastic bowl, the wax spatula for directing steam of liquid duplicating material over the critical area of cast. Also we have many materials supplied by dental suppliers to spray the molds, to spray the casts, in terms of providing a thin separating layer, which is in microns, to make easily to separate the cast later on, or the refractory cast from the mold. Now the equipment we are planning to use, the Gelovit material, which is the agar-agar melting device, which it is set for the agar-agar in terms of gelating the material and to pour the material without any air bubble. Of course, we should have a vacuum mixing device, vibrator, ceramic pot, and microwave oven for rapid direction. All of this will going through the procedure. We are going through the procedure to mention them. Now, the duplication flask is essential to focus on. The cast to be duplicated must be placed in the bottom of the suitable flask, which is the duplicating flask, as at the image on the right side, whether at the top or the bottom. Now, the duplicating flask has two parts, namely the body and the reservoir ring, or the counter. The body of the duplicating flask forms the base of the flask. So the body forming the base of the flask, where the cast to be duplicated is positioned. Now, the reservoir ring or storage unit, where the duplicating material is heated and constantly mixed to improve homogeneity and prevent grainings. This part is a dome-shaped structure with the vent hole through which the duplicating material can be poured in. So it is easily to pour from one side to be the extra going through other side. The reservoir ring is designed such that the flange extension of the dome seat on the body of the flask, the vent hole present on the upper surface of the counter, should be aligned with the dispensing nozzle of the duplicator during the duplicating procedure, and we are going through this step by step. Now, the duplicating flask should contain the fluid material to facilitate its cooling. to support the mold while it is being filled with the cast material and to facilitate removal of the cast from the mold without permanent deformation or damage to the mold. So that's the mold on which we can duplicate, and then after duplication we have a hollow agar-agar duplicate container to be filled with the investment material and to set the material and then to remove the refractory cast from it. So this is essential with the refractory cast. Now, the procedure for the duplication. First of all, we should place the cast on the center of the base of the duplicating. We agreed that we have base and the dome for the duplicating flask. Now place the cast on the center of the base of the duplicating flask and check the height of the cast. So this is to check if everything is perfect and the height is perfect. Do not make the cast height, the base of the cast, higher than the duplicating flask. It is essential to have a suitable size for the duplicating flask with the suitable size for the master cast to be duplicated. Now should be if it is too high, very high, so we need to trim it to provide adequate space to the agar-agar, which is this at least the 4th inch clearance of around the casts. That means about 6 millimeter should be around the cast to give enough material to hold the investment material later on after investing the mold. Now, after we checked everything, now we soak the master cast in a room temperature water for 20 minutes. Place the cast in a rubber mixing bowl, 3/4 filled with clear celery water. This step is done for 2 reasons, of course. First of all, to make the cast completely saturated with water. This to avoid any absorption of water from agar-agar material that may cause dimensional inaccuracy of material. We agree that the agar-agar is a liquid, hydrocolloidal, that means contain water. So if the cast not soaked in a celery water, that means the dry cast will withdraw all the liquid from the agar-agar, so the agar-agar will lose the dimensional accuracy, and later on probably we're gonna have an accurate refractory cast with a smaller size than the original one, which what we are looking for is accurate with the same dimensions. This first of all. The second thing is to fill all pores of a stone cast and displace trapped air, and placing under bell jar and activating vacuum for 2 minutes. This is essential to remove all the pores that we have in stone. Otherwise, what that lead to? Lead to the agar-agar going into these pores within the cast, and this will affect the smooth surface of the duplicating material. We can have a rough surface with the refractory casts with all these noodles due to the pores of the stone, which withdraw the agar-agar into them. Of course, with all of these, under the placing the bowl under the bell jar, okay, activating vacuum for 2 minutes. This to remove, to vacuum all the pores or the air entrapped in the pores material. Now the cast is secured on the base of the duplicating flask with the help of modeling wax clay. Of course, as at the image on the left side here, you can notice these are clays, okay? Clay material on which the cast secured into duplicating flask with the help of model and wax. Sometimes we fill all of these area with the clay material to avoid any trapping of the agar agar inside it, and to give enough space for us later on to here to pour the material from the side to have a flat surface, to pour the investment material. Okay. Here are the fourth of inch, that means 6 millimeter from both of sides, to make it easy for us to hold the material there. Uh, Now, then place the flask over the base and close firmly. Now, after this procedure, we put the dome of the flask over the base and close it firmly, okay? To make sure it's everything perfect. Now, preparing duplicating material in gel of a device between 71 to 100 centigrade. Of course, to liquidate the material, but we should gradually cool it into 52 centigrade or reduce gradually to 52. Let it cool a little bit to 52 centigrade to prevent melting and distortion of the wax that using blocking out under relief. This is the gel of it material on which the material prepared. Now, we can actually melt the material up to 100 centigrade, it's fine, and then leave it to cool to gelo temperature that we are looking for, which is 52 to 54 here. And then pouring the material for the duplicating flask with melting agar slowly from a gel of a device. When the agar completely fills the reservoiring, it will flow out through the other veins present. So filling the material from this side, we're letting the others going from the other side, the material flowing from other side, so the material will flow with the air bubbles. Now, when it's full, we leave it for 20 minutes while the agar agar initially set. The flask is placed in a bath of cool tap water to just 1/3 of the flask. Then the flask is immersed completely in water for 20 minutes to avoid rapid cooling that may affect the accuracy of agar material and cause dimensional changes. Now, this is essential to as I mentioned, the flask placed in a booth of cool tap water to just 1/3 of the flask. Then the flask is immersed completely in water for 20 minutes. This to avoid rapid cooling that may affect the accuracy of agar agar and cause dimensional changes. Now, the duplicating flask should be placed below the dispensing nozzle of the duplicator during duplication procedure. Now, the duplicator has a horizontal table to hold the duplicating flask. The horizontal table is perforated, and a fan is present below the table to cool the duplicating flask. Sophisticated duplicators which help to pour the duplicating medium in a vacuum chamber and also are also available. Now, vacuum-based duplicator prevent porosity in it. All of these are basically represented by the techniques and the suppliers, the equipments that we have within the duplicators. Now, remove the base of the flask and carefully later on we remove the base of the flask and carefully remove the model. The clay used for stabilizing is removed. A jet of a cold air can be blown at the junction of the cast for the set duplicating material to loosen and remove the cast embedded in the duplicating medium. After that, now the final details of the model surface should be clear. Of course, we are going to separate. For example, we can separate with a surfactant eliminates any reaction with the investment material and ensure more accurate casting, that the surface tension, the difference between the investing and the agar-agar, this to relieve this process. Now, now we are preparing the investment material during phosphate material, and mostly we are using phosphate bonded investment material, of course mechanically mixed under vacuum and carefully vibrated to eliminate the trapping air. Then pour the investment material into the mold. Investment material pouring into the mold from posterior region to the anterior region. And this is depend on the technique that the technician used, whether it is from side to side, anterior to posterior, or posterior region to anterior. And after completing fullness, we are leaving it for 1 hour, and it depends on the type of investment material, to set before removing the duplicating material. Now we should have many points to. For lower models, the sprue former is inserted prior to pouring the investment. Here, for the lower, we are using the indirect technique for sprueing. So in this technique, what we are using, we can use the gingival former here before investing the material, putting the investment material. So we will have the this hole, which is directly used for indirect sprueing. Otherwise, if we are using direct sprueing, so no need to put the sprue former within the mold, hold it within the mold to create this hole. Now, once set, remove the agar-agar mold from the flask, and of course using air jet. Look here, we are using air jet after setting the material to make it easily to be removed and do not distort the refractory cast here. Remove the agar-agar mold from the flask and taking care not to damage the model. Then section the agar and remove the section. Now the investment cast should not rinsed or trimmed with cast trimmer, because this will cause slurry of the investment material to splash over the cast, may not be entirely removed by rinsing, so affect the accuracy of the cast. So perfectly are using this we are using the we do not trim the refractory cast at all. The agar-agar can be rinsed with water, of course, and can be reused for the same. We can reuse it in terms of remelted again, or if we have any defect within our investment material, the refractory cast, we can also invest it again. Now, at this stage, the investment cast should not rinsed or trimmed, as I mentioned. Heat the investment model in an oven is essential to hardening it. Okay, so we need to hardening it for approximately 200 centigrade for 60 to 90 minutes to dry the model. This giving a hardening material. To avoid the investment material from chipped off. So first of all, we are hardening it, and then dip the investment cast, which is the refractory cast, in a heated bath of beeswax for 2 to 3 seconds, and allow drying on paper to dispense the excess. We can dip it like this using beeswax here or there, but after the hardening it, we do not dip the cast in the beeswax, then we heat it. No, just after duplicating, we heat the refractory cast, the invested cast in oven at 200 centigrade for 60 to 90 minutes, and then with its warmness, dip it in the beeswax and leave it on a paper up in a way tilted to make it drying on a paper to displace the excess of the beeswax. Now heat the oven, then shut off it, and after beezing the refractory cast, actually at this moment it's not a refractory cast, it's still invested cast. So after dipping in the beeswax, we just turn the oven off and leave it with the warm to let the cast to dry, or just to still warm to the room temperature inside the oven. And this is essential for many reasons. So the dipping the cast in the beeswax for the following reasons are: first of all, provide smooth surface of the cast. That's what we are looking for. When we are creating a removable blush denture framework, the cast should be smooth. So this will be turned to metal and then inserted into the patient mouth with a smooth surface. Now, facilitate the duplication of the wax pattern as the wax adheres better to the spray cast. The application of the wax pattern, we need a uniform media on which we can adhere our plastic wax pattern, handmade wax pattern, or the ready-made wax pattern for removable blush denture. So it is easily when we spray it using the spraying adhesive material to act as a tacky between the wax patterns and this smooth layer, or the wax beeswax on the surface of the of the refractory cast. Also, to prevent the weakness of the cast during handling, this will hardening the cast. It's act as adhering between the cast and the beeswax in terms of not easily be chipped off or handling or scratching the surface. And of course, to provide surface hardness. So if we by mistake we applying the clasp in terms of using spatula or sharp knife, or carving things or smoothing things, so the surface will be hard on this area. Also, this will give a uniform layer on the master cast, which is essential for us at this point to remove this part of the beeswax within the bosom area. And this what we give us the intimate contact of the framework food dam with the patient arch or patient surface palette without bandaging the soft tissue. So it's just removing within the food dam lines or design the beeswax at this point. So all the design will be passive and only the contacts within the food dam. Okay? This is what we have for the refractory cast, and you should know what the benefit of the dipping of the cast. Now, what we have, the refractory cast, after creating the refractory cast, now is the moment we can call this the cast that invested, dipped in the wax, hardening it using the oven. Now it's called the refractory cast, because we are planning now to create or to design or to apply the framework made of wax on it. The refractory cast will have the following characteristic. First of all the blackout undercuts will be invisible in the refractory cast. All the infra-bulge undercuts will be blocked out like this on the refractory cast. So the refractory cast will be like the cast modified, and only the area that on which probably we are applying the clasp there, the ditch for the clasp, for example the stoppers here appear. Okay, all of these will be invisible because filled with investment material. Now the space relief will appear as an elevation on the will be as elevation on the edentulous ridge. Look, this is the relief area that we used, and these are the area we'll leave it for the stoppers. So all design will be there, and this is the stoppers, here the stopper, and this is all the relief area which can be give a space later on where in the master cast. This is the refractory cast. The stoppers holes on the spacer relief will be as a depression. Other relief we have, let's go back to one of the images that I have to show you the relief, for example, all the stoppers here. Here, you can notice here, this is the within the relief and the shaped blockout, we have this hole, and this hole is a stopper. Later on, this will be these are the holes within the relief area. Okay, these will be inserted, the wax framework will be there, and then cast into metal so to act as stoppers. And of course the gingival relief will appear as an elevated band on the refractory, just like this. There is no undercut within the refractory cast at all. All the area that's been blocked out, relieved, will be filled with the refractory material, and only the digits for the clasps, the relief area will be as elevation, the holes for the stoppers, and the gingival area, that's be the relief for the gingival, which are planning to not introduce the metal on them because our minor connector or will be, or the blade proximal blades will be directly on a smooth uprightening without any management, or any undesirable undercut may affect the introducing of the metal inside it and affect the passivity of the removable partial denture. I hope that you now understand the aim of the duplicating, for the duplicating the master cast into refractory cast for the construction of the removable partial denture framework. Now the quiz for the next week is to give the reasons to dip the refractory cast in the beeswax in terms of constructing the removable partial denture. Thank you for today. See you next week to discuss one of the most important parts related to the removable partial denture, and probably the wax pattern. Thank you again.